Hello everyone, in this video I'm going to talk about wayfinding, travel and navigation. Alright, let's get into it. So what are these terms? Okay, so basically wayfinding is a cognitive process of determining and following a route between point A to point B. It requires situational awareness, for instance, creating a cognitive map of the environment, having the spatial knowledge of the environment, knowing where you are in that environment. And then with navigation, which is a term that I usually use that refers to wayfinding, it's basically following a specific route, using all of these knowledge, and you having that cognitive process of determining and following that route. On the other hand, travel is slightly different from wayfinding and navigation. Travel is how you move from point A to point B, all right? What tools you use to do that, all right? I'm going to talk about each one of them. So there's like a very close relationship between wayfinding and navigation. They are related concepts. But wayfinding is a broader term, and that refers to how people find their ways around the environment, creating that cognitive map and using the situational awareness and having the spatial knowledge of the environment, being able to go from point A to point B. Navigation refers to specific means by which people find their way. For instance, navigation map or landmarks that are available in the environment that help us to find our way. So I usually use wayfinding term, but sometimes I use navigation for that, so I use them interchangeably. What I mean by wayfinding and navigation when I use them is basically that cognitive process that helps you to determine a path, a route, to take you from point A to point B using the situational awareness, using the spatial knowledge, and things like that. Wayfinding involves spatial understanding and planning tasks. You need to determine your current location, create a cognitive map, and determine a path that takes you from point A to point B. Wayfinding is always important in any type of game that you're creating. Navigation and wayfinding is like one of the very important parts of any game. But sometimes wayfinding becomes more challenging in virtual reality games because sometimes you have more complex and big environments that are really hard to deal with the technique that are available to us to create those environments. For instance, imagine you have the entire world. How do you find your way through that environment? How do you go from point A to point B without getting lost? So that becomes very important because you're making a very, very real environment much smaller and put it in VR and having people to navigate through that. So now you need to be very creative of thinking about ways to help people to go through that. One great example of that is Google Earth VR, and they did a great job on helping people to go from point A to point B and finding whatever they're looking for. So if you're interested, you can look at this video. You don't need to watch the entire thing. If you go to like sort of like minute 10 or something, they talk about their technique that they use to help people to find their path in VR. So when we talk about wayfinding, the situational awareness becomes a very important part of it. Situational awareness is a user's internalized model of the current state of the environment. Their perception of all the objects, of all of their location in the time and space that they are in, what they mean, and also what their status is going to be in near future. And then we have a spatial orientation, where we are in the environment, okay, and understanding the location and your viewing point. Spatial awareness affects how we interact with the objects around us. We need to continuously keep track of spatial settings in the world around us in which we operate. Otherwise, we get lost. We usually store the environmental information in our long-term memory, and we refer to them as cognitive map. When we are performing wayfinding tasks, we use this existing spatial knowledge, and we also continuously creating new spatial knowledge. And sometimes we use a combination of both to go about the environment, understand the environment, and create that cognitive map that continuously help us to find our being in the environment and being able to find where we need to be. There are different types of spatial knowledge that helps people to uh, find their path. There are three of them: landmark knowledge, which consists of visual attributes of an environment, including shape, size, and texture. We also have procedural knowledge or route knowledge, which describes the sequence of action required to follow a certain path or to traverse paths between different locations. And we also have survey knowledge, which can be described as a configurational or topological knowledge of an environment, consisting of object location, inner object distances, and object orientations. The wayfinding is as effective as the number and quality of the wayfinding cues that we provide to our users when they are playing a game. There are different types of cues and aids that can be provided to the player. We have user-centered wayfinding cues and environment-centered wayfinding cues. And in the next few slides, I'm talking about those wayfinding cues, and I have the general wayfinding cues combined with VR focused one, and I will point them out as we talked about them. So let's talk about user-centered. So basically, you need to allow a wide field of view. Okay, so if you have the bigger field of view, helps user to understand where they are in the environment, collect more information from the environment. Provide motion cues, where they are headed, what is their speed, and things like that. Provide audio cues for your users to enhance their visual spatial perception. The other two that I listed are more related to VR, and one of them is minimizing the mismatch between your sensory channel and the information that you're receiving in virtual world, and then the other one is using the sense of presence that we have in VR to help people, to help users to create that cognitive map. When you're creating the environment, make sure you use wayfinding principle to create the environment. Some of those wayfinding principles that we use in real world are, for instance, natural environment principles, such as horizon, such as fog. So if you have a horizon, if you see your horizon, helps you to sort of understand where you are in that environment. Or architectural design principles such as lighting, such as texture, color, shadow. You can use all of that to help user to understand the objects around them and understand where they are in that environment. And then we have artificial cues such as signs, maps, grid, and things like that. So you can use all of those information, the combination of these principles, to help your users to understand and have a better wayfinding. The whole purpose, though, when we are talking about wayfinding, is to have a way of helping user to find their way without requiring too much cognitive load. Okay, so your wayfinding cues and aids must be in a way that helps them to know where they need to go and how they can go there. Okay, so they can understand and create that spatial knowledge, create that awareness of the environment, and be able to figure out the route. And then they can travel from the point they are to their destination easily without even thinking. There are some games that do a great job on that. Like for instance, Super Mario Brothers is one of my favorites. You can only move in one direction, and you can only just move forward and jump and do things like that. So it's very obvious. And then the information that you're getting from the environment helps you to just go forward. So the cognitive load in that game is extremely low, helping people to focus on the fun of the game and helping them to focus on the objectives of the game rather than figuring out how to go from one place to the other. So although wayfinding is a big process, should be like a huge burden for the designers, not for the players. So the whole goal is to make it super intuitive so players just go and play it without even thinking. So for your game, what I want you to do as an activity is think about why wayfinding is important in your game and when you can apply wayfinding. So is there any method that we talked about that I can use to improve the wayfinding in your game? All right, so next I'm going to talk about travel. All right, so travel is how you physically move from your current location to your destination. For instance, are you using a mouse or keyboard, joystick, touchpad, wand, or are you in VR and you're naturally moving in the environment to get from one point to the other? So what is important for travel when we are talking about travels in games? Again, travel is important in every game that we are creating. It is also becomes problematic more in VR, okay? So for instance, if you're creating a VR game, you need to make sure you minimize sickness. But in any game that you design, you need to have high accuracy and high precision. By accuracy, I mean you move where you want to go, and by precision, I mean you move consistently. The movement must be smooth. Whatever game that you have, it shouldn't be laggy or something that makes people to get frustrated. You should have learnable techniques. It shouldn't be super difficult to understand how you need, how can you move from one place to the other. It should be natural, believable technique that fits within the context that you have. And it should also support for multitasking. There are different types of travel that we have. We have exploration or browsing, in which you don't have any explicit goal and you just want to collect information from the environment, and it needs continuous direct control and ability to stop. The other type of travel is search. It has a specific objective in this case, and you may not know how to get there. So you need to search the environment and to find what you're looking for. And then we have maneuvering, which needs a small, precise movement in your local area. You need to find a balance between precision and the speed to basically travel accordingly. Travel have different taxonomies. For instance, what is moved? Is it self-motion, object motion, or viewpoint motion? Another taxonomy that we have for travel is continuity of motion. For instance, is it continuous, or is it partially continuous, or is it discontinuous? We also have interactivity. Is it active or passive? And then we have motion cues provided taxonomy. For instance, full motion cues or partial motion cues, and so on. So whenever we talk about travel, there are two very important pieces to that. And one is where you're facing and what is your position. And if you have those two pieces of information, it helps you to figure out how to go about and travel. So I'm going to conclude this lecture here, but the PowerPoint slides that I'm going to post on Canvas are going to have much more information, and those are regarding VR. Okay, so if anyone is interested to understand more about travel in VR, you can take a look at the rest of the slides, okay? So basically in VR, there are more limitations. For instance, you need to reduce motion sickness when you're traveling in VR. And you can do and use different methods to do that. For instance, a couple of things that I put here, shrinking the field of view, raising off the ground, or minimizing the duration of different sensory mismatch that you have in the environment, and so on and so forth. There are like many methods that you can use to minimize sickness in VR. There are like many examples that I have in there, so if you're interested, you can take a look at the slides that I posted, play the videos to see like some good or bad example about each one of them. And if you have any question, please let me know. All right, so you have a great day, and I see you shortly.